Okay guys, I'm going to use that equation from the last problem that we did in the other video. Y equals 5x minus 1. It doesn't matter what order you write the y equals in. This is the proper slope-intercept form with the y first, but if you can recognize it in this form too, that's fine. Okay, I'm going to go ahead and show you what the graph looks like. It would look something like this. You might recognize this from today's lesson and be able to see where it crosses the y-axis, and you would know the slope is 5, so you might have an idea of what that line already looks like. But we're going to review a couple of the other concepts, a couple ways to graph this line for those who still might be struggling. So the first way that we learned to graph the line was plugging in values for x and y. We made a table of x and y values. I think the book had you do 3 or 4 points along the line and then draw a line through those points, and that would be the graph of that line. So a line will have a value of x for every possible value on that number line, because this keeps on going. X would have a value at negative 100 and then positive 100 and even further. We don't want to graph something that far, so we're going to choose points that are closer to the origin just because they're easier to work with. So let's start by picking maybe the point 0, because that is an easy number to work with. All right, so if I say x is 0, all that means is I'm plugging in 0 in for x in this equation. And then the only variable left is going to be y. So this is telling me when x is 0, what does y equal? When x is right here, where is y on that line? So let's plug that in. If we have y equals 5x minus 1. If I say y equals 5x is 0 minus 1, y is going to equal 5 times 0. Well, that's just 0, and then we have minus 1, so y is equal to negative 1. This is a point on the line, so at 0, negative 1, this is the x value, this is the y value. At 0, when x is 0, y is negative 1, right there. Well, let's say we want to figure out where y is when x equals 1, positive 1. Well, let's plug that in to that same equation. What does y equal when x is equal to a positive 1? Y equals 5 times 1 is 5, minus 1, well, that is just 5 minus 1 is 4. So when x is 1, y is 4. That is another point on that line. So when x is 1, y is 1, 2, 3, 4. And all you need to graph a line are 2 points. It doesn't matter where those 2 points are, you connect those dots and you will have a line. Now another way we learned today to graph the line is by using the slope-intercept form. Y equals mx plus b. So if y equals 5x minus 1, that means that the y-intercept, b equals y-intercept, that is where the graph of the line crosses the y-axis. M is equal to the slope. Okay, so at B, the y-intercept is negative 1. So let's say we didn't know what that graph looked like and we had to graph it from this information. Y is negative 1. It crosses the y-axis at negative 1. And it has a slope, the m value, the number in front of the x, is 5. That is the same as 5 over 1. So the slope means you go up 5, 1, 2, 3, 4, 5, over 1. Up 5 over 1. It's a positive 5, so we know it's going to look like this. This would be negative, this is positive. So the line goes that way. And your graphs can be this imperfect. They don't have to be on graph paper. They don't have to be super precise. I just want to see a kind of clear where that those points are. If for some reason they're kind of wonky, just label them for me. The point is at 1, 4, and this is at 0, -1. Another way that you can graph the line is by using the x and y intercepts. So to do the x-intercept, that is saying where on the graph does the line cross the x-axis? Wherever that graph crosses the x-axis, wherever that line crosses the x-axis, the y value is going to be 0. Say it crosses way over here, that y value is still going to be 0. If it crosses over here, that y value is going to be 0. So to find the x-intercept, plug 0 in for y. So using that same equation, y equals 5x minus 1. If we plug in 0 for y, we find out y equals 5x minus 1. So all we're doing now, we have one variable left, we solve for that variable. So we add 1 to both sides, and that gives us 5x equals +1. Well, now we need to get x by itself, so we have to divide both sides by 5. Because this is saying 5 times x, the inverse of multiplication is division. So those would cancel out. X is equal to 1/5. So that means that when x is 1/5, y is 0. So I'm going to draw my spaces a little bit bigger. When x is 1/5, y is 0. Somewhere in there. Now what if we wanted to find, well, I'm running out of room. Let's say the y-intercept. We do the opposite of what we did here. On the y-intercept, that is saying wherever the line crosses the y-axis, the x value is going to be 0. If the line crosses down here, x is going to be 0. If the line crosses right here, x is still going to be 0. Plug 0 in for x. So, well, this one's kind of easy. Y is equal to 5x minus 1. If we plug in 0 for x, we are given 5 times 0 equals 0, so minus 1. Y equals -1. So if x is 0, y is -1. That is another point on that line. So we have 2 points. That's all we need to draw what that line looks like. Now let's say we have a problem that says 2x minus 4y is equal to 10. What if we're given an equation and we are asked, is point -2, 4 a point on that line? Is this point on the line? So what we would do is simply plug in these values for the x and y here. Remember, this is the x, this is the y. So all we're doing is plugging in a -2 for this x and a +4 for this y. So let's do that. 2 times x is -2 minus 4 times y is a +4. Does that equal 10? Well, let's see. -4 minus 4 times 4 is 16 equals 10. That is -20. Well, that does not equal 10, so the answer would be no. That point does not lie. This point is not on that line. What if they said, here's an equation Tell me a point. Tell me a point on that line. Well, there are an infinite number of answers for that because that line goes forever and ever and it crosses an infinite number of points. So you can pick any value for x or any value for y, solve for the other variable, and that would give you a point. So let's try, I don't know, let's try 3. Let's see what, if we want to pick a point, let's pick x for 3 for x, and figure out what the y value will be when x is 3. So all we did was plugged in 3 for x right there. So we have 6 minus 4y is equal to 10. So we're just solving for y. So let's move 6 to the other side. So that's 0, and we're left with a negative 4y is equal to 10 minus 6, that's 4. All right, let's divide both sides by negative 4 so that we can get y by itself. So y is equal to negative 1, because 4 divided by negative 4, that's a negative 1. So when x is negative 3, y is negative 1. That means on this graph, this line with this equation, 3, 1, 2, 3, negative 1, that graph will cross this point, 3, negative 1. What if we, instead of solving for, picking a number for x first, like we did here, what if we picked a number for y first? What if we want to see what the value of x is when y equals 3? That means when y is somewhere in this area, where is x? Well, to do that, we would take that equation and put 3 in for y. So let's say 2x minus 4 times 3 equals 10. That is 2x minus 12 equals 10. So to get x by itself, we move this 12 to the other side, and that's 0, so we're left with 2x is equal to 22. That's 10 plus 12. Well, now we need to divide both sides by 2. 2 times what equals 22? X is equal to 11. So that means that when the y value is at 3, x is going to be way over here. Let me redraw that right here. 1, 2, 3. Our first point is 3, negative 1, 4, 5, 6, 7, 8, 9, 10, 11. Wow, way over there. Okay. When x is 3, when y is 3, the x value is going to be way over here at 11. And our line would look something like that. Very rough sketch. So at any x value, if we pick a value for x, we could solve for the value for y, and vice versa. If we picked a value for y, we could solve for the value for x. All right, if you have any questions on that, definitely let me know. This is foundational for all of the maths that you will do through the rest of high school. Drawing lines, solving for the variables of certain graphs. Right now we're just doing straight lines, but eventually you'll get to parabolas and hyperbolas and lines that are cubed, things that look like that. So super important stuff. So if you have any questions, definitely let me know.